Welcome. Today we shall refer to this lecture number 3, in which I talked about the sources, distribution and processing of natural gas. In this particular lecture, I would like to clarify a few points regarding the sources of natural gas. So, I will be talking about the non-conventional sources of the natural gas. Here first I take up the shale gas. The shale gas, as you can see, is formed within some fine grained sedimentary rock, and this sedimentary rock means there layers after layers are being formed, and these particular rocks are characterized by their brittleness. So, they are easily breakable into thin and parallel layers, and these rocks are formed by the compression of the various materials over a long period of time, like say about few hundred millions, few million years. And the oil is extracted from this particular type of reservoir, oil or gas, by some destructive distillation. Next comes the coal bed methane. Now you see the coal bed methane or the shale gas, both are coming under some deposits. Now the difference is this, in the case of coal bed methane, this kind of gases happen only in the coal mines. What happens that in the coal mines, as you can see in the figure, that here is the coal bed, and all these various kind of organic materials, they remain entrapped, and you know that is how over a period of long time these get converted into coal, and when it happens, the decomposition leads not only to the formation of the coal but also some organic hydrocarbon gases like methane, ethane, etc. Now methane, as you know, is the smallest possible hydrocarbon that can formed when we are kind of dissociating and destructing the higher hydrocarbons. So ultimately means all the bigger hydrocarbon chains are broken up and they form the smallest hydrocarbon, that is the methane, and this methane again remains entrapped within the coal bed by the force of adsorption. That is, some kind of physical bonding is there between the coal particles and the gas. So this is the gas which is the coal bed methane, and to get this gas out, what we do is this, because this gas is there under high pressure, and the process of adsorption is favored at high pressure. So to get this gas out, what is done, that we have to make a way so that we can reduce the pressure so that the gas can get dissolved from the surface and come out. And this desorption is done by doing this pumping, and you can see that there is some water beneath the coal bed. So this water starts coming out also. So as the water starts coming out, the gas is also coming out because there is the loss of the pressure. And what happens that because this gas and water are not soluble, so these two materials from two different phases, so it is not very difficult to separate these two materials, that is water and the methane gas, and you can see that the water is coming out to one conduit, whereas the gas is coming out from another conduit, and this is how we are able to get the methane from the coal bed. Now only thing is this, that even though it is as we know that it's a non-conventional, means the rate of methane formation or methane extraction is what matters. So even though it might be possible to get some amount of methane from the coal bed, but one thing we have to remember, that the production rate should be similar to the ones which we are getting from the natural gas reservoir. This particular source of natural gas in terms of the rate of production does not yet match with the ones we are getting from the natural gas reservoir. The next gas source, natural gas source, is the tight gas. Now the tight gas, as you can see that the name suggests that it is there in some tightly formed rocks. So when I mean tightly means in terms of their permeability. So if any substance has very low permeability, then we call it tight. And what is permeability? Permeability is the ability of a material to allow some fluid to pass through it. So in that way we can say that we have some porous material and non-porous material. So porous material have high permeability, whereas non-porous material have very low or zero permeability. So when I say tight gas, it means that the rock formation is having very low porosity, and that is how it has very low permeability. So in such kind of formation, some of these gases are formed, and naturally when they are formed in such tight sources, it becomes more difficult for us to extract this type of gas, and this permeability is generally given in terms of the Darcy. This you can see that it is about 0.1, less than 0.1 millidarcy, or sometimes we call it MD. So this is the kind of rock which we have for the tight gases, and to extract this kind of gas, what is done, that we break the rock or acidize it so that we can get the gas out, and naturally this technology proves to be quite costly because of the effort we need and the kind of destruction we have to do to the tight gas formation that may lead to other kind of problem in the geological problems in terms of landslide, etc. So all those problems have to be also taken into account when we are going for this kind of production. And the last one in this non-conventional source of gas is the geopressurized gas. Now geopressurized gas is also formed under sediment, but now this type of sediment generally occur in some basin means in the sediment basin under the sea. So this is subsidizing sediment basin, means these basins starts kind of they can sagging, and this they kind of due to the pressure from the top they start compressing. So this kind of basin is called subsidizing basin. So in this kind of formation, in this subsidizing basin, this kind of gas is trapped. So it is called geo means the geological pressure. So this is geopressurized gas, and this kind of thing may happen in both onshore offshore. Onshore, that means on the land, and offshore means in the sea. So in both sea and on the land, this type of gas may occur, and these geopressurized zones are naturally underground formation. Naturally, because if you want the geological pressure to be applied, then they have to be under sufficient depth under the earth. So this sufficient depth may be there onshore or may be there offshore. So this kind of gas is formed under the very highly pressurized zone inside the earth. So that is how we can see that the four types of these non-conventional sources of gases are differentiated depending on, first, their occurrence, second, the way that the type of the formation, type of rock where they are occurring. In that way these are differentiated. Thank you.